Hey guys, thank you so much for joining this month's session. And today we'll be discussing on creating building cloud-ready apps with .NET Aspire and AWS integration. So this is I'm redoing this session. I did the session at 9 o'clock, but for some reason I forgot to add myself in the stream of the StreamYard. So the event, the video has come out, but without voice. So I am redoing this session. Uh, that's it. Thank you. So this is a session, and here is my GitHub account. I will post it here just for others' benefits. It will be here. That's the GitHub profile. And the coding for today will be under this GitHub account. So that's also I'm giving it here for your reference. So you have the GitHub account as well as where the code is there. So you have a lot of documentation also there, and I think we are good to go. So let's start discussing on this one. What is that we are going to do? So we'll speak about introduction, what and why, developer environment setup, and provisioning AWS resource with CloudFormation, and connect .NET projects to AWS stack, and implement S3 upload and front end. We'll see that. Okay. So first I want to show real quick without even discussing anything how our application looks, how it works. First I want to show that. So we are executing the host app host application first. So that solution, we will execute it and then we'll start from there. So let it execute. In the meanwhile, we'll wait and watch. Okay. Okay, it's taking a little time. Should be fine. So let's wait. It will give the control. I'll close this so that we'll get some memory free. So here, if you see that for a fraction of a second, it showed running, and here it is failing to provision the resource. We'll see why. So you can go and look at the console. So, okay, it says that this is already existing. So that is the reason it is failing. So I will close this and let me go to cloud, AWS cloud. And we need to go and wait here. That's the S3, and let me open up the CloudFormation also here. So the CloudFormation has failed because I already created. That's not the reason why it failed, and it also did the rollback. So let's give that another shot. If not, I will delete the stack and we will recreate it. So first, let's see how it executes. Okay, so we can go back to, let's wait until it gives the control. Okay, it gave the control. Now I can go directly to the console and look at the Aspire. So it is trying to do the update, and it says that Aspire is already existing. This one, Aspire AWS Images Dev. So that's the name which I have given to to the infrastructure. Okay, sorry. That's the name which I've given to the infrastructure and the resource template. That's the one. So let's see if we have the images one. I think that I do not have that, if I'm right. So let's see. I'll do that. I created images dev and images 2 dev. Images 1 doesn't exist. So let's go and look at the stack. So it went and it created this. Then let's come back to the resource. So if you see, everything is running. Now let's come back to the AWS. Let me refresh. So we'll see that S3 bucket with the name dev1. Where is that? Okay, this is the one. So it has created images dev1. So let's go and just do a trial before we starting the discussion. I just want to show how the things look. So let's do it in two ways. First, we will check with the API. So I've added a scalar. Previously, we used to have Swagger. Now we can use the scalar also. So let me upload some of the any one of the file. So I have a screen print. So let me upload this one. Screen prints. So let me upload this file. So the file is here. And before that, let's see. It should be in page 1. Let's upload this. We'll see. It is there, but for some reason it's not showing. So upload failed. The specified bucket doesn't exist. Then why did it say the bucket exists in the logs? In the logs, it told output. Oh, okay, I understood the problem. Okay, I understood the problem. So 1, 2, I use those names. Or else best what I'll do is I'll take this off. Let me delete this one, empty the bucket, and permanently delete. Let me copy this and drag into this box. Click on empty. Okay, bucket is empty. Now let's just exit and we'll see we have this. Let me select it and click on delete. And let me copy. I mean, there were few files which I tried yesterday. Last night I was trying. So let me delete the bucket and let me delete this too. Suppose if you want to do further experiments, we need it. So let me do, oh, it's not create, I'm sorry. Let me select it and delete that. Okay, bucket is empty. Permanently delete. I mean, I've given all these steps as part of the troubleshooting part. I gave it. So it shouldn't be a big thing. Let's come and let's delete this one also. We had to delete that. So now we deleted. So we don't have those buckets. And alternatively, we can come and delete these stacks also. So let me delete this stack here. Okay, now that is being done. So what I'll do is I'll just do a reversal of this. We don't want the name to be changed. Let it be the image itself. So the first thing is, I mean, this we didn't even start what is what, but before that, I just wanted to show how things execute before we start and discussing why and what. So first, let's give the demo to see how the application works, and then we will start digging deeper and finding out. Now, if you come back to the logs, and let's go into this resource. So this is the one which is initiating, and we saw that the stack itself was not available. I mean, it was available. We deleted that, and okay, here. So you can see that we go, and then it started all these things, and we can see the events over here, what is that it is doing, and the type of resources which it created a bucket, and it created a bucket policy. We'll see that where that is available, we see that bucket has been created. Now when we go into that S3 bucket, we see nothing exists over here. Okay, so now that's it says that done. Somewhere it should say that CloudFormation, it says is complete. That bucket it created, and it created the bucket policy, and the stack itself is up and running. So now if you come back here, we see everything. In the previous one, when we saw that, because as I tried multiple times, the one I tried in the previous session when I was doing at 9 o'clock without voice. So at that time I created two. So at that time it said that no resource has been created, because it didn't find in local. It will have that in the stack where you see this here in this CloudFormation. It will have the memory like what is the resource it created. Now if you try to execute it, it knows that. If you see that, it knows that it has created a bucket policy and bucket. I mean, actually it's not checking whether it exists or not, but based on this it is taking the decision. So that's what I understood in the previous one. Even though the bucket one, image one bucket doesn't exist, but it says that no change needed. So now that it has created, let's come back to this. First we'll go to the Scalar. Previously I used to use Swagger. Now I'm using Scalar. So let's come back to the Scalar v1. Once we'll execute this, then we'll set up the context. What is that we are doing, why we are doing. So before that, let's see whether things are working or not. So let me come here and upload the file and click on send. And before that, we saw there is nothing in this bucket as of now. And now it has uploaded. And BD189, that's the GUID. Now you can see that BD189. So that means we were able to upload an image from the web API or the middle tier to Amazon S3. Now let's come back to the UI, where we'll see the UI integrated with the API. So I'll select another file. This file, I'll select it, and I click on upload. I mean, we'll come back and we'll discuss, but before that we have to set, this is what is the one. Okay, so that's it. Now let's set up the context. Now what is that? Why are we doing it? Now let's start with the demo script. So the first thing is we need to understand why are we doing this Aspire in combination with AWS. So the Aspire is a framework which is helping us. Let me come back here. We'll see quite a few things in this documentation. We'll compare with what we have. So if you see this Aspire, it helps us in creating a production-ready distributed application. Okay, so the first thing out of this is called orchestration. So if you see that here we see not SDK, not this one. I just wanted to, from the concepts perspective, we'll see something known as a orchestration that will happen in the app host file. So we'll see that over here. Let me stop this, and we'll discuss step by step. So if you come and see at the orchestration, the distributed application. So here you can see this one. This is what is composing or creating the distributed application. Okay, and imagine a scenario where some of the resources it creates locally in our Docker container. Some it uses, if you want, it will use the cloud resources, or if it supports, we can use those also in our local. So one documentation I want to open is AWS with Aspire. If you see this here, uh, Aspire with AWS. So here in this, we see this provisioning of resources. We did that part. We'll come back. So we can create some of the resources, SQS or DynamoDB, some of those things which we want, we can create it in Azure. So you see this that will happen. I mean, AWS. I'm from the Azure world, so I might interchangeably or use sometimes the Azure specific terminology. Apologize for that. So some of the things which you wanted to be locally used, like integration, Amazon DynamoDB local. So that means you don't need to provision this resource in AWS, but you can have it in local. So first we'll speak about the orchestration, then we'll speak about the integrations, then we'll speak about the service defaults. Okay. So the first thing is orchestration is where it is bundling all these things. So once I execute it again, so here you will see this. The couple of things are here we are creating the resource, all the resources in AWS cloud, and this resources are being provisioned in the cloud. So we saw that just now we saw this has been provisioned here, the S3 bucket. And the second thing is there is a cache. When we came previously here 5 minutes about that time, there was no container. Now it has created and it will match with the name over here in our Aspire dashboard. This is the one. See, Redis cache. It has created this one. Okay, so that's one thing. Now the second thing is we saw one is cloud resources, one is container, and there are two microservices. One is API, one is front end. So we saw that one is API and one is front end. So this is, it is bundling all these things and it has created a distributed application and it executed. So that's the first part of the equation. So is the orchestration. So we can have resources locally. All the, if those resources are integration are provided, we can use it locally, or we need to depend on the cloud. So if you come and see from the integrations perspective, let me check this one. Okay, so if you see this Apache Kafka from Azure perspective, you can see local Azure provisioning, lot of these things, AI inference, AI search, Azure Cache for Redis, Cosmos DB, Key Vault, all of those specific to Azure is under this node. And then you can see that Elasticsearch, Entity Framework, Key Clock, and a lot of other things are there. And somewhere it should have the DynamoDB are very specific, but those things we will get it here in the AWS information. Like if you come and see this AWS one, you can see at the top the Aspire hosting AWS, this library, this NuGet package. If you go to this NuGet package, you will see that what all the things which are available. Okay. So, and also they gave us a sample template which creates the SQS, which we will do it in the next episode. But at least to a decent extent, we will know that how the things importing an existing AWS resources and provisioning using AWS CDK. You can use AWS CDK to provision the resource, but we are, for this episode, we are using the cloud this one CloudFormation stack to create the resources. Okay, so some of the things which we will do dive into this, at least touch those things to a decent extent. But if you see this NuGet package supports, and we can go deep into the weeds to find out what other hosting it supports. We can get into this package explorer, and we can look into that, what other things which we can take advantage of. That's the readme. Let's get into this lib. Okay. Oh, no. So you can see some of those things here, right? So these are the things which are, or what we can do is we can directly go to the site itself. Here, integration on .NET Aspire for AWS. And there we can see, get into maybe the test or the resources which they are supporting. We might get some information here itself. Let's go to the Aspire. So at least we can see that CDK and CloudFormation, DynamoDB, Lambda, something from the provisioning perspective. So other things we can get from the sample or test files, whatever they have written. We'll know that what all the things which they are supporting. Unit test, if you go into the unit test, this will definitely give us a clue what all the things which are getting, like SQS, Lambda, and other things are getting provision. Okay, that's cool then. So we spent quite a few minutes to understand what is this orchestration means. App host, what does the app host does. Now let's look at from the integration perspective. So the integration perspective, those are the NuGet packages which simplifies the connection to the specific resources and different platforms. Also we have seen that Redis and Azure Redis cache, also we have seen Redis and Postgres, and we have seen MongoDB, very specific to others also, like RabbitMQ, Quadrant, and different things which we have seen here. Okay, now Keycloak. These are the services, but the NuGet packages makes it very easy to integrate with those resources. And if you come and see this from the integration perspective, so from the integration perspective, we need to know two things. One is hosting integrations and one is client integrations. So what is hosting integration? Let's take the example of this Redis cache itself. So if you come and see the code here in the, first look at the NuGet package. So Aspire hosting AWS. Okay, Aspire hosting AWS or Aspire hosting Redis. So that is the hosting integration, that which provision the resources like container or local resources or the cloud resources. So these are the packages which does the app host does this integration. So that is hosting integration, and there is something known as a client integration. Now if you see that Aspire hosting Redis, this is the hosting integration. It is being done from the app host. Now if you double click the web and you see this here, Aspire Stack Exchange Redis, this is the microservice or the client application which is using this. So that will be the client integration. You can see this somewhere. We have already seen this one, Aspire Stack Exchange Redis. You can see that Aspire Stack Exchange Redis, and in that there is output caching or different mechanisms are there. But net we understand that something, the integration which happens in the app host is the hosting integration, which starts with the package as package with this name format. You can know that Aspire.hosting, those are hosting integration, and the client integration will be very specific, like Aspire Stack Exchange or Aspire.Microsoft.SQL client, data.SQL client. Those kind of things will be uh, client integration. So we saw that this is a client integration over here. Now, what is the relationship? So as we were discussing that app host. So the hosting integrations which happen inside this app host project is the um, hosting integration, and the client applications will use the client integration. So that means, let me close all these things and double click this. Here you can see that we have created the Redis cache here. Okay, so this is one of the resource. I'll come back to that, and that is being injected in the front end. So here, so now when we go to the front end, here you can see this add Redis cache output cache. So this clearly says, or which we can identify that this is an Aspire client integration. So the hosting integration is happening over here. We are hosting this client, that means the resource, Redis resource, and we are injecting that inside the front end. And when we come to the front end, we see that builder.add Redis output cache, and you can see that clearly if you go through this documentation, it clearly knows that this is what we are doing as part of the client integration. Like if you go to the top, you can see that assembly, you'll get more information, but this is the client integration. Okay, so we saw at a broad, uh, the Aspire helps us to create a microservices solution very easily. The distributed application, we call it as a distributed application. It helps us easy. Now we understood like what is app host, what is orchestration, what are integrations, inside integration, what is hosting integration, what is client integration. Okay, we spoke about that, and now we will be talking, see these integrations. We saw that, see everything Kafka, this is hosting integration, this is client integration. Dapper only hosting, Elastic, Keycloak, Milvios, I think I'm pronouncing correctly, MongoDB hosting and driver, MySQL both, and Nats messaging both, Oracle EF Core, Orleans, and MySQL, Postgres, and Quadrant, RabbitMQ. A lot of these things are here, and you can see those libraries are also being supported. And another important thing which we have to look at here, project template, is this the service defaults. This is very important topic which we have to discuss. So let's go to this service defaults. So what is service defaults in any microservices solution or a distributed application? You definitely need telemetry, health check, service discovery. So if you come and see, we spoke about app host project, this one. Now we'll talk about this service defaults. It's just an extension file, and this file contains the service discovery, I mean open telemetry, health check, service discovery with standard resiliency. Now if you come and see this open telemetry, we have metrics and tracing, and the health check, and these defaults. So let's see what are these and how it is helping us. So we'll see that what is this and how it is helping us in creating. So let me execute it for the second time. So I'll come back to directly go to this one. Now upload another file. I've uploaded the another file. Then I'm coming to home. Then I'm coming to counter page and I'm clicking on this. I'm going to weather, and this is using Redis cache. You see that numbers are not changing for 10 seconds, and now it has changed 1 and 44. So it will be output caching this for 10 seconds, and now 10 and 31. Again, you can see that. Now again, I can come in and do another file upload. Which one? I'll upload this file. Okay, so all these things are there. Now we can come back. Here we can see this. First thing I want to show here is tabular view. All the resources, whatever we are having in our distributed application, and this will have the graph view. You can see this. The as per AWS stack is a label which we have given. All these things are labels. So if we go into the app host, you can see everything, whatever we specified. AWS as per stack resources, that's the label, and cache, that is the label, and API service, that is the label as an identifier. I mean, Web Frontend is another label as an identifier. So from the resources view, we have two types, whether we can see it in a tabular form or a graph form. And in the console, we can go and look at a specific services or a resource specific logs, whatever we are spitting will be here. We can go and look at back in time, what's happening, why did it fail. If at all we are spitting the perfect logs, it should be there, like uploaded the image. This is the log which is coming in from here. Then we can come into the structured logs. And if you see at the top, let's see, here we did an upload of an image. So this is the content root path. Now let's look at the traces. Now this is the trace where you can see this. That's a web frontend. Begin invoke .NET from JS, and then it did a post, and that came to the API, and that is talking to the S3 bucket. So put call. So that put call was success in 1.56 seconds. So the entire API took 2.28 seconds, and the web frontend took 2.4 seconds. So now if you see that combining the JavaScript and the entire operation, it took 3.35 seconds. And here we can see the breakup. The traces, we have seen the structured logs, we have seen the traces. We can get into the metrics, go and select the service where you want, and you can see that the graph format, what happened, and all these things, the tons and tons of wealth are available. So these two are from the tracing perspective. If you see that at the top, we saw that here the metrics and the tracing. So, and the logging also, we can see that open telemetry and health check are there. Service discovery is one important thing which we have to discuss. So the service discovery is, suppose if we deploy this to any cloud or on-premise, the middle tier will be in one, will be deployed as a service, and front end will be deployed as another service. Both will have its own IP address. In a typical deployment, I'm talking about, not always, but the typical deployment. So API service will have its own resource and its IP, its FQDN, and the front end will have its own IP and its own FQDN. Now, assume that API has been deployed in another other part. So that means an IP address might change or FQDN might change. So if FQDN changes and web frontend has got a previous FQDN, again we need to change it. And there are automation tools. It's easy. It's not sky is not going to fall if the API has changed its FQDN. It's an easy, but there is a task, and there is a risk that if we forget, we might break the front end. But that is little bit we need to take care. But now what happens is when we marry all these resources through the Aspire template, what happens is the Aspire itself, we saw that service discovery is one of the things it is taking care of, like add service discovery. Now let's go and see this. Inside this, it will inject these values. So when we were discussing about the API service and the front end, if API service FQDN has changed, we should not. I mean, the front end should not worry because that is getting injected directly by the Aspire. We'll see that. This is an API service. Now, if you go deep into this, at the bottom, you can see that the services API service HTTP is this and HTTPS is this. So you can see this HTTPS is 7558 and 5406 is HTTP. So if I click on this, we see these addresses 5406 and 7558. So it is properly injecting these values as part of the service discovery. It knows that, hey, this is the address where this resource, in the sense API resource, has been deployed. So it will help the front end to find where this API service is deployed. Okay, so that's about the service discovery. So let's quickly recap. What did we do? So we started discussing with what is Aspire. Right? It is providing set of tools and templates, packages to create production ready, cloud ready applications, distributed applications. Okay. So, and also we saw that what is orchestration, and we saw integrations, hosting integrations, client integrations, and then we saw about the types of integrations. We saw quite a few things which we saw that, and also we spoke about the service defaults, where we spoke about the items which it is helping us, like telemetry. We saw service health checks, service discovery, standard resiliency, and let's discuss about this a little bit. So from the packages perspective, you can see this resiliency, service discovery, telemetry, hosting extensions, Aspire instrumentation, HTTP runtime. You saw that traces and structured logs and all these things are getting from here. And now if you see the app host, that project will have reference to the microservices. That means API and web. But if you see the service defaults, it doesn't refer anything. But anyone who wants to take the advantage of all these things, resiliency, service discovery, I'll stop here. I mean, you want to take the advantage of service defaults, then that particular microservice should refer the service default. Like you can see this, the API service and the web front end, they will refer the service defaults. Now this is how it goes, guys. App host will refer the microservices like API service and front end, and API and front end will refer the service defaults because it want to take the advantage, or it has to take the advantage whatever this service default is providing. Okay, now you got the dots connected, I think. And another very important thing is when we come to the hosting here, in the hosting, here we are seeing here builder.add project, and it is saying that Aspire stack.api and Aspire AWS stack _web. So what are these? These are just a string label. Like if you see this projects, that's a namespace, and this is a variable. When you click on that, it goes, this is auto-generated code. We should not meddle with it, and we might invite problems to ourselves. So this whatever code it generates, let's use it. So it's nothing but the project path. You see this? Now let me come back here. That's an API path, and this is the web app path. You can see that where is the physical location of this project, the CS project. It's just as simple as that. When we are seeing that add project and we give this API reference, and add project will give the web frontend reference. Those are nothing but just a string which has got a path to the CS project. So I think now we have a decent knowledge on what and why. Okay, so that's what we took this much time. And now let's see the stack I have. So .NET 6, 7, 8, 9, and 10.5. Okay, those are the one. And let's see, are we ready? So what all the things we needed, we can execute this. So it says execution policy, PowerShell, and AWS CLI is there. And I did the configuration. Docker is installed, and CloudFormation template is also formed. So the CloudFormation template is not a big thing. So it's a pretty simple one. Again, AWS S3 bucket resource template. If you click on that, directly you will click on this link that will take here. Directly you can come in, and you can we can do a diff also with this, what we have in our infrastructure. And you see the same the parameters. Let's ignore that. The type, we see this type is same, and the name we specified, and these four are false. And then status, something is there. And course configuration we configured because we want to view it from outside. And you can see the bucket policies, what it should allow. So we used these bucket policies, and the output we have used same. It's exactly, we can do a lift and shift and customize. It's not a big thing for us. Let me come back where we were. What is that we were discussing? So this is from the cloud template perspective. Okay, and another important thing I want to show is that, let me come back here. So let me close this, and I think this NuGet package also we have looked at, and this one also we looked at to a decent extent. This I'll keep it. This will come back and we'll do it in a next episode. Okay, so these are the couple of files which we have uploaded. Now let's come and see a couple of other things which are very important. So this we verified. Now we saw the, look at this. So you can see all the project resources. There are main 4 projects are there. And we discussed about the service overview. We saw metrics, structured logs, service dependency, and we didn't do the health check. And we looked at the tracing. We looked at it. We did a detailed demo. We looked at the scalar, and we tested the endpoint, and we uploaded the file. But again, we'll come back. And hot reload we didn't check, and we can do that. Service architecture configuration, we have seen that. And anything else left? Okay, so now we'll come back to some other concept which will which we will see. So here we are using the build props. So the advantage of this build props is we don't need to specify these tags at different places. That means here if you come and see the three elements, .NET Framework, implicit using, and nullable. So I will nuke this from this project. Okay, and I'll go to the app host, the same three elements which we specified in the build props. And again here I'll nuke the three things, and again I remove this entirely. And now let's execute. This is one of the advantage. Anything you want to define at one place, it will be easy. So that means right now we have only 4 projects. In your microservice solution or a distributed architecture, you might have 6 solutions or 8 solutions or 10 different projects in your solution. So here it's only 4. Even though it has 4, suppose if I want to migrate it to .NET 10 from 9 to 10, or I want to degrade from 9 to 8. So I have to go and modify that in 4 different places. So we can see that solution is working fine. Even if I remove those elements, it's not troubling us. And another thing which I want to show you is, suppose if I come back here and for some reason I want to update it to 10. And let's see, I will execute this. Right now we were working on .NET 9. Now because I have installed .NET 10 preview 5, and if the packages or the dependencies are missing, it will break. If not, seamlessly it should definitely work. So let's see if it is working. So if it's working, it proves that the migration process from one framework to other framework is also happening seamlessly. It doesn't take much of our time. Again, if the packages also has to be updated, then we need to update it. But assuming that there are no packages, major packages differences, we have successfully migrated our project from .NET 9 to .NET 10 without even worrying. And within 30 seconds, we were able to execute our project from .NET 9 to .NET 10. Now this project is being executed in .NET 10. So is there a proof? I don't know, but we can go and check together. Let's go here, and in the console, let's see the API service. And does this show the front end? There you go. See, now it's using the .NET 10. So those are using .NET 10. So now 2 minutes ago we were using .NET 9, and now we are using .NET 10. How simple it is from A to B. Okay, so that's one thing. Now let's see some of the negative. That's one thing. And another thing is we need to definitely speak about this. Now if I want, I'll switch it back to .NET 9. I want to show something else. .NET 9, and here the packages, all the packages are centrally we have defined, and this tag will be package version. This label will be package. Any of those packages inside your projects, you will mention package reference, but you will not speak about the version number, because all the packages are being managed centrally in this file, packages file, directory.packages.props, where you will define the package numbers, where you will say that, oh, these are the packages which I'm going to use. You are locking this version, and inside the CS proj, you will never ever mention the package numbers. If you mention the package numbers, it will not compile. So we'll see that. If I go back and mention the package number here, and let's do a build of this, and it's clearly failing. We saw that there were a fail, and it says that project that uses centralized package version should not define the version in individual project. So that means all the versions will be defined at one place. So we should not define. So I'll build this again. And another advantage is, let's assume the output caching we are using, and we define the output caching version in the centralized package management. And here we have four services, or let's assume for the argument sake, or for the discussion sake, we are using the same output caching in more than one service. So the advantage of not mentioning the version is we can happily use this in multiple projects. Sometimes we do that if you are using the same library in multiple projects within our microservices or distributed solution, there is a bright chance that we might use one version in one of the microservice and another version in another microservice. There is a bright chance. I'm not telling that definitely we all will do this mistake, but there is a bright chance we might do that. So this will save us. You don't need to mention the version at any place. You mention this package version centrally and then use at different places. Now comes the AWS integration. So here we are saying that in the hosting, AWS hosting, we have mentioned it. So let's come back to this one, this AWS hosting. Now we can see, if I click on this, if I go here, so from the AWS, there'll be a lot of other things. We can do a deep dive into this library itself to find out what other things are available, like from the resources perspective. Each and everything are in a different places, but at least you can go and look at this package and see what other things it will support. We saw that it's in .NET 8. This package has been written in .NET 8, but we are able to consume it in .NET 9 and .NET 10. We saw that we are able to consume this AWS library and communicate. So let's see how the API is communicating. We saw that. Let's come back and look at it from the program perspective. We will, every time whenever a microservice is using the service defaults, the first thing it should call is add service defaults. That one it should call. And apart from that, we are using this Amazon AWS, Amazon S3 client. And if you go and look at this image service, and that image service is this one, Amazon. It is using this Amazon S3, and the bucket configuration, we are lifting it from there. It's very simple. We are creating a GUID format, and we are prefixing the image ID with this request file for the S3 key. Now put object properties, we are defining this object properties, and this one underscore S3 client, if you go and see, that is being injected by this constructor, parameterized constructor. So it is doing a put async, and once that is done, we are retrieving, and the response, we are spitting it out. That's it. It's pretty simple. And here in the web frontend, what we are doing is we're creating this one. And from the service discovery perspective, this is very, very important. Now, if you see that, what is this label? This label is an identifier. We have defined this in the app host. You can see this in the app host. We have defined this API service. Now, if I go in here and search the entire solution, find all. So it's not in the README, not in the Docker file, not in here, not in here, not in here. Yeah, here. In the program CS. So in the program CS of the Aspire host, we are defining this. And in the web front end, we are using the same label. See, whatever you have specified in the double quotes in the app host, we are using the same label here. And what is that we are specifying? Expose HTTPS and HTTP port to this particular microservice. And because of this, the Aspire template as part of the microservice discovery, service discovery, it is injecting these values. We saw that. So see this, we are adding the HTTP weather client, also image upload service. Image upload service is this one. So the base address for those two, we are using this one, API service. So when I execute this one, when I execute that one, we will know how these values are getting injected. We'll see that in a minute. So let it show. In the meanwhile, I'll have a glass of water real quick. So here you see this. And we said that we want to support both HTTP and HTTPS. We can get into this. Here, view details. And you can go as part of the environment variables, a lot of these things like what should be the HTTPS ports and what is the ASP.NET URLs. So very specific to this one. And AWS profile, AWS region, and other values. I don't want to flash it that now. And here the launch profile is HTTPS. That's the reason it is executing in HTTPS. That's a launch profile. And other values, OLTPs and other things. But here, service name, we know that what is this service name. Here we are seeing the URL, and this is the display name of the service. Now if you come to the same view details of the front end, again we see that what is the front end URL. Again we are supporting both HTTPS and HTTPS, on what resources it is waiting on. And we didn't configure any health check. But if you see, apart from we have this cache also. Now it is the responsibility of the Aspire to give you the connection string. We are not defining connection. We didn't define this password also. So we have created it as part of the hosting integration. And Aspire created it. It injected its connection string. Everything is taken care by the Aspire. And also here we said that we want to support both HTTP and HTTPS. We have seen that. Now it is giving us the service discovery where it should be provided. Okay. And also we have seen quite a few times, we have seen that how to upload the file and how to view that. So I think to a decent extent, we have covered what I wanted to cover for today in as part of this demo script. Let me check that if at all I missed anything. We'll see. If not, I think we discussed this one and we saw local S3 we didn't do, but service orchestration, hot reload, we didn't do that. Rest everything we have covered. and we discussed about the cloud formation also, how the logs, and if something goes back, it rolls back. We saw this, and we did to a decent extent, we did a deep dive into this and where it will fail. The troubleshooting also I've given, if at all, it troubles us, where should we go and delete that? That also I've given. I think that's it from my side. Thank you guys for joining. And again, I didn't realize that I didn't move my image or profile to the stream inside the StreamYard, and that was the reason. Previously, when I recorded at 9 a.m., it came blank. There wasn't any voice, and now we do have a voice. Please watch this. So, in the next episode, what are the fundamentals which we have built today? We will build on top of that. So, we'll focus more on SNS service and DynamoDB. We'll build those two services, SQS, Q messages, and DynamoDB. So we'll build that and try doing something related to this. Like when someone uploads an image, we should make an entry into the DynamoDB table and drop a message in the queue, get someone notified in another UI or something. I'll see what best I can do, at least to a decent extent, mix these three, S3, SQS, and DynamoDB, enhance the same project, do a little bit of facelift of the UI, and let's see. Thank you so much. Have a good rest of the day.